Hello and welcome to Pre-Algebra Lesson 46. In this video, we're going to learn how to find the mean, median, and mode for a group of numbers. Alright, so again, the lesson objective for today is just to learn how to find the mean, median, and mode for a group of numbers. Alright, so let's start out with one that you're probably already familiar with, even if you've never heard it called the mean. So the mean, otherwise known as the average, and that's probably what you've heard it as, of a group of numbers is found by adding all of the numbers for the group, then dividing by the number of numbers in the group. So it's very, very simple to find an average. All right, so find the mean. And again, you could say find the average if you want. Those two words are interchangeable. So we have our numbers here. We have 6, 12, 13, 5, and 9. So all I need to do is find the sum to start. So let's just do this using a vertical addition. I'm going to put the two-digit numbers on top. So I'm going to put 13, then 12, then we could do 9, then 6, then 5. So again, you can add in any order. I just did this because it's kind of a way for me to organize it in my head. All right, so put my addition operator out there, and let's start adding. 3 plus 2 is 5, 5 plus 9 is 14, 14 plus 6 is 20, 20 plus 5 is 25. I'm going to put a 5 down, carry a 2, 2 plus 1 is 3, plus 1 is 4. So I've got 45 as my sum. Okay, so let's erase this real quick. And I'm just going to write here that the sum is 45. Now the next piece of information is we need to know how many numbers are in the group. So I can just go through and count. That's pretty easy. I just go 1, 2, 3, 4, 5. There are 5 numbers in the group. 5 numbers in our group. So to get the average, I just take the sum of the numbers in the group, which is 45, and I divide by the number of numbers in the group, which in this case is 5. Now, I don't need to do a long division for this. I know 45 divided by 5 is 9. So the average here, or the mean, is going to be 9. Okay, let's take a look at another one. Let's say we have 28, 34, 115, 7, 2, and then 6. All right, so let's find the sum first. And again, I'm going to take the numbers with more digits and put them on top. And again, just to keep this organized, I'm going to take and just list them in descending order, right? Starting at the top with 115 and then just moving down. So to 34, then 28, then 7, then 6, then 2. Okay, so let's start our addition. I'm going to scroll down a little bit. So 5 plus 4 is 9. Plus 8 is 17, plus 7 is 24, plus 6 is 30, plus 2 is 32. So let me put a 2 down and carry a 3. And let me scroll up a little bit so I can put this 3 up here. And 3 plus 1 is 4, plus 3 is 7, plus 2 is 9. Then I can just bring this one all the way down, and I have 192 for my sum. So the sum is 192. Now, how many numbers do we have in our group? Well, we have 1, 2, 3, 4, 5, 6. We have 6 numbers in the group. So I just take the sum for the numbers in the group divided by the number of numbers in the group, and then I have my average, or again, the mean. So what is 192 divided by 6? Well, I don't really work with those numbers very often, so I don't know that off the top of my head. I would need to crank out a long division. So let's do that real quick. So what is 192 divided by 6? 6 will not go into 1. It will go into 19 3 times. 3 times 6 is 18. Subtract them, we'll get 1. Bring down the 2. 6 goes into 12 twice. 2 times 6 is 12. Subtract and get 0. So 192 divided by 6 is 32. And again, 192 divided by 6 is 32. And so this is our answer, right? Our average, or our mean, is going to be 32. All right, let's take a look at one final problem for finding the mean, or again, the average. I have 125, 17, 22, and negative 7. So let's add all these numbers together. And what I'm going to do, since we have a negative involved, let's add the positive numbers together first, and then let's do a final operation where we add the result to that negative. So what is 125 plus 22 plus 17? 5 plus 2 is 7, plus 7 is 14. 4 down, carry the 1. 1 plus 2 is 3, plus 2 is 5, plus 1 is 6. Bring down the 1. So I've got 164 I'm going to have 164 plus a negative 7. So obviously 164 is larger in terms of its absolute value, so the answer is going to be positive. Essentially, I just have a subtraction problem here. 164 plus negative 7 is the same thing as 164 minus 7. So we do 164 minus 7. Borrow here, this will be 5, this will be 14. 14 minus 7 is 7. Bring down the 5, bring down the 1. So I get positive 157 as my answer. So let's write that the sum is 157. And then the number of numbers is 4, right? I have 1, 2, 3, 4. So the number of numbers in the group is 4. So now I would just want to take that sum, which is 157, and divide by 4, right? The number of numbers. Again, something I don't work with a lot, so I have to do a long division. And so 157 divided by 4. 4 will not go into 1. It'll go into 15 3 times. 3 times 4 is 12. Subtract, we get 3. Bring down the 7. So 4 is going to go into 37 9 times. 9 times 4 is 36. Subtract, and we get 1. So to continue this, I can put a decimal point and bring it up into the answer. Put a 0 here and bring that down. 4 goes into 10 twice. 2 times 4 is going to give me 8. Subtract, and we'd have 2. Put another 0 and bring that down. 4 goes into 20 exactly 5 times. 5 times 4 is exactly 20. Subtract, and we get 0. So we get 39.25. So we get 39.25 as our answer. Again, this is the mean, or what we call the average. All right, so another way to think about the middle value for a group of numbers is to use the median. Now, a lot of times when you hear data on people's salaries or on house prices or things like that, things that are affected by very high and very low values, you'll hear people talk about the median. So the median is not affected by these kind of outliers, these large values that kind of pull your average up, or these low values that kind of pull your average down. For example, if you thought about salaries, let's say you had 5 salaries and it was like 52,000. Let's say another one would be like 58,000. Let's say you had one that was 64,000. Let's say another one was 60,000. So these are all relatively close together. So your average should be somewhat representative of, what these values are. It would be close. But let's say for my 5th one, I throw in something like $18 million. Well, what happens is when I take the average here, I'm going to get a number that doesn't really accurately represent what the salaries are, right? It's inflated. From this kind of outlier here, this was way above what everything else was, and it pulled my average up. When we look at the median, we're going to correct for that. So we're not going to be affected by these very large or very small values. And essentially, to find the median for a group of numbers, we just arrange the numbers from smallest to largest. So the smallest goes to the left, and then we just keep going to the largest. The median is going to be the middle number when the number of numbers in the group is odd, or the average of the two middle numbers if the number of numbers in the group is even. Okay? And that's a lot to sink in. You might want to write that down as a note and just use it as you're practicing. But once you do a few examples of this, you'll kind of have it down. It's not very, very hard. All right, so we want to find the median in these examples. And we're going to start off with a pretty easy one. We have the numbers 3, 9, 8, 1, and 12. So again, the first thing you would do is arrange the numbers from smallest to largest. So I'd start out with 1, then 3, then 8, then 9, and then 12. Okay, so smallest number goes all the way to the left, and then we just, the next smallest, the next smallest, the next smallest, and then finally get to the largest value. Now, we have an odd number of numbers here. We have 1, 2, 3, 4, 5 numbers, and so the median is simply the middle number. In this case, that's going to be 8, right? It's going to be 8. And you can tell that's the middle number because I have the same number of numbers that come before it, right? I have 1, 2 numbers that come before it as that come after it. I have 1, 2 numbers that come after it. So 8 is the middle number and therefore the median. All right, so for the next one, we have 150, 25, -2, 14, 18, 3, and then 9. So we're going to start out with the smallest number, which is -2 all the way to the left. Then we'll go to the next smallest. That's going to be +3. And then we're going to have 9, then 14, then 18, then 25, then 150. Now, how many numbers do we have in this group? We have 1, 2, 3, 4, 5, 6, 7. So again, 7 is an odd number. So we know that it's just going to be the middle number here. So that's going to be right here where this 14 is. I have 1, 2, 3 numbers that come before it and 1, 2, 3 numbers that come after it. So 14 is your middle number or your median. And when you get to your statistics class, or if you're reading a statistics book, you might see a formula in there that tells you that if you have an odd number of numbers, the median position is at n plus 1 divided by 2. N is just the number of numbers in your group. So you have 1, 2, 3, 4, 5, 6, 7 numbers in the group. So you'd replace that with a 7. 7 plus 1 is 8. 8 divided by 2 is 4. So essentially, you would be looking for the number that occurs in the fourth position. Well, this is the first, the second, the third, this is the fourth, and there's your median. All right, and that works when you have an odd number of numbers. All right, let's look at some scenarios where you have an even number of numbers, and you're going to see it's a little bit more tedious. So we have -2, 4, 6, and 5. So to arrange the numbers from smallest to largest, I need to flip the order here. I'd have -2, 4, 5, and then 6. Now, there is no middle value here, right? If you kind of look, okay, 4 looks like it's kind of in the middle. It has 1 that comes before it, but 2 that comes after it. Then if you look at 5, okay, that kind of looks like it's in the middle. 2 that come before it, 1 that comes after it. So neither of those is going to work. And essentially what you need to do is just treat these two numbers here, 4 and 5, as if they're in the middle. Okay, 4 and 5 as if they're in the middle. And you can see you have one number that comes before and one number that comes after. Now, because it's two different numbers here, what they want you to do is find the average of those two numbers, right? Kind of the average of the two middle numbers. So if I average those numbers, I would just sum 4 and 5. 4 plus 5 is 9, and then I would divide by 2. What is 9 divided by 2? 2 goes into 9 4 times. 4 times 2 is 8. Subtract and get 1. Put the decimal point there and bring it up. Put a 0 and bring it down. 2 goes into 10 5 times. 5 times 2 is 10. Subtract and get 0. So the average of these two numbers, 4 and 5, is 4.5, and that's your median. Your median is 4.5. Again, the average of the two middle numbers. All right, let's look at one more here. We have -8, 14, 2, 155, 30, 7, 5, and -2. So again, I'm going to arrange the numbers from smallest to largest. So -8 is the smallest, then -2, then +2, then we'd have 5, then 7, then 14, then 30, then 155. And if you count the number of numbers here, again, we have 1, 2, 3, 4, 5, 6, 7, 8. So again, it's an even number of numbers. There is no true middle number. If you kind of think about it, okay, well, if I have 8 numbers, that means that kind of these two numbers here that occupy the 4th and the 5th position. So this is the 1st, the 2nd, the 3rd, and I'm kind of messing up the writing on this. So let me kind of make that clear. So the 2nd, the 3rd, the 4th, and the 5th. If you look at these two numbers, you have 3 numbers that come before and 3 numbers that come after, if you just kind of block those two off. So those are your two middle numbers. They're your two middle values here. And you just want to average them to find your median. So you would add 5 plus 7, you get 12. Divide that by 2 and you get 6. So the median here, again, is the average of the two middle numbers, and that's going to be 6. All right, let's talk about probably the easiest one to find, and this is called the mode. So the mode for a group of numbers is the number that occurs most often. That's it. You just have to find the number that occurs most often in your group of numbers. And it's important to note here, let me highlight this, that we can have more than one mode. So if you had a group of 6 numbers and each number appeared 3 times, let's say you had something like, I don't know, 3, 3, 3, 7, 7, 7. The mode here is both 3 and 7. Right? You have 2 modes because each number, 3 and 7, both appear the same number of times. And so you would have 2 modes. It's different than if you had something like 3, 3, 4, 6, 8, 2. Here, the number that occurs most often is 3, and so you have one mode, just 3. right? 3 occurs twice. Every other number occurs just once. All right, so we're going to find the mode for each group of numbers. And basically, you just look through the numbers and see what occurs most often. So you have 82 and 86, 104, 82 again, 75, and then 30. So your mode is 82. The mode is 82. And why is that the case? Because 82 occurs twice in this group of numbers, and each other number occurs only once. So again, the mode is the number that occurs most frequently, and 82 occurs twice, whereas every other number occurs only once. So that's why our mode is 82. All right, here we have 103, 27, -4, 2, 27, 3, 2, 27, and 104. So I know 103 only occurs once, so I'm just going to kind of cross that out. That's not the mode. 27 occurs once, twice, 3 times. And let me use a different color here. -4 only occurs once. 2 occurs once, twice. 3 only occurs once. 104 only occurs once. So the mode here is going to be 27. You have 1, 2, 3 occurrences. 2 came close. It had 2 occurrences, but 3 has the most, and so that's the mode. So your mode is 27. Okay, for the last one, we have 333, 75, 81, 75, 621, 79, and 333. So you can see here, just by eyeballing this, that you have 333 and 333. You have 75 and 75. So you have 2 modes here. 333 and 75 each occur twice. Everything else occurs only once. So we'll say that there are 2 modes. And those are 75 and 333. Hello and welcome to Pre-Algebra Lesson 47. In this video, we're going to be converting between US units of measurement. So our lesson objective for today, we want to learn how to change between US units of measurement. All right, so we're just going to start by looking at the relationship between a few common units of measurement. We're not going to cover all the possibilities here, but just a few of the basics so that we can kind of get our brain thinking about converting units. All right, so we have here length. So here are 3 common ones. We have that 12 inches equals 1 foot. We have that 3 feet equals 1 yard. And we have that 5,280 feet equals 1 mile. All right, let's look at weight. We have that 16 ounces equals 1 pound. And we have that 2,000 pounds equals 1 ton. For volume, we have that 2 cups equals 1 pint, 2 pints equals 1 quart, and 4 quarts equals 1 gallon. And then lastly, for time, we have 60 seconds equals 1 minute, 60 minutes equals 1 hour, 24 hours equals 1 day, and 7 days equals 1 week. Now, based on the circumstances of your life, you may know all of these, you may know none of them. So try not to stress out too badly about memorizing these right away. As you work a lot of practice problems, you will memorize these relationships very, very quickly. And a lot of them you probably already know. For example, 60 seconds equals 1 minute. I think everybody knows that. Or 60 minutes equals 1 hour. 24 hours equals 1 day. So on and so forth. So the ones that you don't know, as you work through the practice problems, you'll pick it up very quickly. So let's start out our lesson by just asking a simple question. If we are asked to convert 5,280 feet into miles, it's pretty simple. So we know that 5,280 feet is equal to 1 mile. And we saw that earlier when we were looking at the provided relationship between units. But what happens when we want to convert 6,600 feet into miles? So if I said 6,600 feet equals how many miles? Well, let's go through the process so that we can get the answer here. So our first step is just to set up something called a unit fraction. And let me highlight this because this is going to be important for you to know. A unit fraction shows the relationship between units and has a value of 1. So that part is very, very important. The fact that it has a value of 1, because remember, when we multiply by 1, even if it's a complicated form of 1, like we saw with fractions, it does not change the value of the number, right? If I take the number 4 and I multiply by 3 over 3, right? This is a complicated form of 1. So 4 times 3 is 12 over 3. 12 over 3 is the same thing as 4, right? If I do the division, 12 divided by 3, I get 4 back. So it's going to be the same thing here. We're going to be multiplying by a complicated form of 1. For example, if I have 5,280 feet, and that's equal to 1 mile, well, if I write 5,280 feet over 1 mile, this is going to have a value of 1. Right? It's the same thing over itself, right? It's the same distance. It just looks different because it has different units involved, right? This has feet, and this is based on miles. So now that we understand what a unit fraction is, to actually perform the conversion, again, you identify the relationship between the units. So in our case, again, 5,280 feet is equal to 1 mile. If you didn't know that from memory, you'd have to look that up and then gain that relationship. Now, the next thing you want is to write the unit fraction with the unit of measure you want to end up with in the numerator. So recall that we had 6,600 feet, and we wanted to know how many miles. How many miles? So the unit I want to end up with is miles. This is what I'm trying to get to. So I'm going to write the unit fraction, again, with the unit measure you want to end up with in the numerator. So because I want miles in the numerator, I'm going to have 1 mile over 5,280 feet. This is my unit fraction. Remember, this has a value of 1. And it's just about taking the relationship between the units and putting, again, the units that you want to end up with in the numerator. I want to end up with miles in the numerator, so that's why I wrote it this way. If I was doing something where I was converting to feet and I wanted to end up with feet, I would just flip this. I would have 5,280 feet on top. I would have 1 mile on the bottom. All right, then we want to multiply what you're trying to convert by the unit fraction. So let's go ahead and do that real quick and see what we come up with. So we had 6,600 feet, and we're going to multiply this by the unit fraction. Again, it was 1 mile on top over 5,280 feet on the bottom. Now, the reason we want the units that we want to end up with on top is because this is what we're going to end up with. The units that we're trying to get rid of are going to cancel out when we write it this way. Feet over feet will just cancel, so we don't have to worry about them. Basically, what I have here is, forget about this unit for a second. That's going to just carry itself over. So we'll put miles over here. And we're just going to think about, okay, what is 6,600 times 1 over 5,280? Well, basically, that's just a division problem, right? It's 6,600 divided by 5,280. And we would just divide this. We know that this will only go into 6,600 once. And multiply 5,280. And we're going to subtract. 0 minus 0 is 0. I need to borrow here. So this will become 5, and then this will become 10. So now we can do 10 minus 8, that's 2. 5 minus 2 is 3. 6 minus 5 is 1. Now we're going to continue the division. So let me scroll down here so we have room to do this. I'm going to put my decimal point here and bring it up into the answer. Put a 0 here and bring it down. So for 5,280, how many times can I go into 13,200? Well, if you just eyeball this, if you just approximate this number to 5,000, 5,000 times 3 would be 15,000. That's too big. So the best we can do here is 2. I'm going to put a 2 here, and I'm going to multiply. 2 times 5,280. Let's do that down here. So 5,280 times 2. 2 times 0 is 0. 2 times 8 is 16. 6 down, carry the 1. 2 times 2 is 4, plus 1 is 5. 2 times 5 is 10. So 10,560. So 10,560. So again, let's subtract. 0 minus 0 is 0. And we need to borrow again over here. So I'm going to borrow from this 2. This will become 1. This will become 10. 10 minus 6 is 4. And then we need to borrow again. This will become 2. This will become 11. 11 minus 5 is 6. And then 2 minus 0 is 2. 1 minus 1 is 0. So I have 2,640. Let's put another 0 so we can continue the division and bring that down. And so we'll have 26,400 now. So if I kind of eyeball this again, I know 5,000 would go into 25,000 5 times. So I know it's at least a 5. Let's think about this 280 part. So let me go down here again. So 5,280 times 5. What would that give us? 5 times 0 is 0. 5 times 8 is 40. So 0 down, carry the 4. 5 times 2 is 10. Plus 4 is 14. 4 down, carry the 1. 5 times 5 is 25. Plus 1 is 26. So this is exactly what we're looking for, 26,400. So we know that the answer here for 5,280 goes into 26,400. That's going to be 5. So 5 times 5,280, again, is 26,400. Subtracting gets 0. So I just need this part, this 1.25. I can erase everything else. And basically at this point, I can just answer this by putting 1.25 here. And our unit conversion is done, right? It's actually that simple. Probably the harder part is just memorizing the units if you're required to do that. If your teacher gives you like a little cheat sheet, this is actually a piece of cake, right? You're just multiplying with fractions basically. So 6,600 feet is equal to 1.25 miles. And again, all you do is you multiply what you start out with by a unit fraction where the relationship you want to end up with, in this case it was miles, so we have mile up here, is in the numerator. If you can just remember that, this is no harder than just multiplying with fractions. All right, let's take a look at another one. So we have 360 seconds to minutes. So what's the relationship between seconds and minutes? Well, I know that 60 seconds equals 1 minute. So again, this is always your first step. Just show the relationship between the units. How much of one is equal to how much of another? Now I'm going to set up a unit fraction. So I'm going from seconds to minutes. All right, so I want to end up with minutes. So that means I'm going to write this where I have minutes in the numerator, or in this case, because it's singular, I'm going to have 1 minute in the numerator. So I'm going to write 360 seconds times, again, 1 minute's going to be in the numerator, over 60 seconds, that's going to be in my denominator. Let's scroll down a little bit and get some room going. Now, once you've set this up, you've basically done all the hard work, because seconds over seconds is going to cancel. I don't need to worry about the units anymore because I know this is what's going to be left over. And that's what I was trying to get, right? I wanted this in terms of minutes. So I'm just going to write minutes over here. And I'm done with that part. Now I can just think about, what is 360 times 1 over 60? Well, it's basically the same thing as 360 divided by 60. And a lot of us can do that in our head by this point, right? 36 divided by 6 is 6. And basically we have a trailing 0 on each one, right? So you can just think about this as 36 times 10 up here over 6 times 10, right? Kind of break that down in your head. This over this is 6. This over this is 1. So basically we're going to have 6 minutes. But again, if you can't do that at this point, I don't want to lose anybody. We can just do our basic division, right? 360 divided by 60. 60 doesn't go into 3. It doesn't go into 36. It goes into 360, again, 6 times. 6 times 60. You can do 6 times 6, that's 36. And then put a 0 at the end, that's 360. Subtract and get 0. So again, we're going to get 6 minutes for our answer here, right? 360 seconds is going to be equal to 6 minutes. All right, let's take a look at another one. We have 15 quarts, 2 gallons. So what's the relationship between quarts and gallons? Well, this is one that a lot of us know because we buy milk, right? 4 quarts is equal to 1 gallon. So 4 quarts is equal to 1 gallon. So now that I know the relationship between the units, I want to end up with gallons, right? So because I'm going from quarts to gallons. So when I write my unit fraction, I'm going to put gallons, or in this case, 1 single gallon, in the numerator. So I'm going to have 1 gallon in my numerator, and I'm going to have 4 quarts in the denominator. And that's the trick, right? Just remembering, hey, the units I want to end up with, that's always going to go in the numerator. If you can remember that, again, you're going to be good to go. And we're multiplying this by 15 quarts. 15 quarts, what we're starting with. And again, the units here are going to cancel. This cancels with this, and we're just going to be left with this. And again, that's what we want, right? We're going 2 gallons. So now I basically have 15 times 1/4, which is the same thing as saying, what is 15 divided by 4? So let's do that down here. What is 15 divided by 4. 4 doesn't go into 1, but it will go into 15 3 times. 3 times 4 is 12. Subtract and get 3. Let's put a decimal point here and bring it up into the answer. Put a 0 here and bring that down. 4 goes into 37 times. 7 times 4 is 28. Subtract and get 2. Put another 0 and bring that down. 4 goes into 25 times. 5 times 4 is 20. Subtract and get 0. So 3.75 is our answer. So 3.75. And of course we have gallons. And you can kind of think your way through that one. If 4 quarts gives you 1 gallon, well, yeah, if I had 12 quarts, that's 3 gallons. That's this part right here. And then I have 3 additional quarts, right? 15 minus 12 is 3. That's not quite enough to make another gallon because I need 4 quarts to make another gallon. So I just have 0.75 or 3/4 of a gallon remaining, right? So that's how I end up with this 3.75 gallons when we convert over from 15 quarts. So another thing you need to know is how to do multiple conversions in one shot. So I have here that you can also carry out multiple conversions in one shot. Let's suppose that you don't know the relationship between cups and gallons. So let's say that you're told to convert 25 cups to gallons. So what you know is that 2 cups equals 1 pint, 2 pints equals 1 quart, and 4 quarts equals 1 gallon. So using this information, we're going to go from cups to gallons. Okay, we're going to go this way. So let me just write these out real quick. 2 cups is going to be equal to 1 pint. 1 pint. And then 2 pints is going to be equal to 1 quart. 1 quart. And then lastly, 4 quarts. 4 quarts is going to be equal to 1 gallon. 1 gallon. So if I'm starting out with cups, which is right here, and I want to go to gallons, which is right here, I would first just think about converting cups to pints. So let's start out here. We have 25 cups, and I'm going to multiply this by 1 pint over 2 cups. 2 cups. Now, why did I do that? Well, again, I want to convert to pints to start. If I want to convert to pints, it's 2 cups equals 1 pint, so 1 pint is in the numerator, right? Because I want to go 2 pints, and 2 cups is going to be in the denominator. Now, this right here now would be in terms of pints. After I do this multiplication, it'd be in terms of pints. So I'm going to multiply again. Now I'm going to go to quarts. So I have the relationship between pints and quarts. I want to go to quarts, so 1 quart's going to be in the numerator. It's going to be in the numerator. And 2 pints is going to be in the denominator. Again, just put the units you want to end up with in the numerator. So this is going to put it in terms of quarts now. Now the last step is to put it in terms of gallons. So I have 4 quarts equals 1 gallon. So I'm going to multiply one more time. Again, gallons will be in the numerator, so 1 gallon will be up top. And 4 quarts will be on the bottom in our denominator. Okay, so this will put it in terms of gallons. And that's all it is. You're just doing multiple conversions at once. And if you're not comfortable with this, just do it individually first. Just do a part where you go, okay, 25 cups, I'm going to convert that to pints, stop, then convert it into quarts, stop, then convert it into gallons. But once you get good, you want to just do it all in one shot like this. Okay, so let's go through, and you can cancel out all the units. You're going to see that cups will cancel with cups, pint will cancel with pints, quart will cancel with quarts. All you're going to be left with is gallon right there. And let me kind of make that a little better. I cover up that 1. So you're just going to be left with this in terms of gallons. So now all we need to really think about is what numbers are involved. Because I know my units, I'm going to end up with gallons. And so I would just think about 25 times 1/2 times 1/2 again times 1/4. What's that equal to? Well, I know that I could just write this over 1. Just think about multiplying the numerators. 25 times 1 times 1 times 1 is just 25. And for the denominators, 1 times 2 times 2 times 4 is the same thing as 4 times 4. That's 16. So we have 25 over 16. That's just a simple long division. So 25 divided by 16. 16 will go into 25 only once. 1 times 16 is 16. Subtract here, we would get 9. Right? If I borrow from the 2, I put a 1 there and a 15 here. 15 minus 6 again is 9. Put my decimal point here and bring it up into the answer. Let's put a 0 here and bring it down. How many times will 16 go into 90? Well, 5 times 16 is 80. That's as close as we can get. So let's put a 5 here. Again, 5 times 16 is 80. If we subtract, we get 10. Put another 0 and bring that down. 16 goes into 100. I know 16 times 5 is 80. So 16 times 6 would be 16 more, or 96. Again, that's as good as we could do. So we'll put a 6 here. 6 times 16 again is 96. Subtract, we would get 4. Right? If I go through and do the official procedure, borrow here, this will be 10, and then it'll be 9, and this will be 10. 10 minus 6 is 4. 9 minus 9 is 0, and bring down that 0, I would just have 4. So I'm going to put another 0 here and bring that down to give me 40. So how many times will 16 go into 40? Well, only twice. Only twice. 2 times 16 is 32. Subtract, and we're going to get 8. Right? Borrow from the 4, this will be 3. This will be 10. 10 minus 2 is 8. Put a 0 here and bring that guy down. Now I have 80. And we know that 16 goes into 80 exactly 5 times. 5 times 16 is 80. Is 80. Subtract and get 0. So we have our answer of 1.5625. So 1.5, let me scroll over a little bit so I can get some room going. 625, and then gallons. And it really is just that simple. We started out with, let me see if I can fit all this on the screen. We started out with 25 cups way over here, and then we went through and we converted basically one at a time, but in one shot, right? We converted to pints, then we took pints and we converted to quarts, then we took quarts and we converted to gallons, and then we ended up with our answer, which was, again, 1.5625 gallons. All right, let's take a look at one final problem. And we want to convert 4.5 days to minutes. So let's start out by looking at the relationship between minutes and hours. How many minutes are in an hour? Well, we know that 60 minutes equals 1 hour. And then how many hours are in a day? Well, 24 hours are in one day. So then now 24 hours equals 1 day. So we're going to go from minutes to days. So not really that complicated here. If we start out with 4.5 days, we're going to multiply by a unit fraction where hours is going to be in the numerator, because our first step is to convert from days to hours, right? We're trying to get to minutes. So I'm going to put 24 hours in my numerator, and I'm going to put 1 day in the denominator. Again, always what you want to end up with in the numerator. So this will put this in terms of hours. Now I'm going to multiply one more time to get it in terms of minutes. Right now I need to go from hours to minutes. So I want to end up with minutes, so minutes will go in the numerator. So 60 minutes in the numerator. And this will be over 1 hour. That will be in the denominator. And now this will be in terms of minutes, which is what we want. Right? We want to end up with minutes. Let's scroll down here. And you can see everything's going to cancel except for minutes. This will cancel with this. This will cancel with this. And this is what I'm left with for my units. And basically I just have 4.5 times 24 times 60. Right? It's just a multiplication problem at this point. So let's go down to a scratch sheet. What is 24 times 4.5? So 24 times 45. Forget about the decimal point for now. 5 times 4 is 20. Put a 0 down, carry the 2. 5 times 2 is 10, plus 2 is 12. So erase this. 4 times 4 is 16. 6 down, carry the 1. 4 times 2 is 8, plus 1 is 9. We'll add here, bring down the 0. 2 plus 6 is 8. 1 plus 9 is 10. So that's 1,080. Let me go back up here real quick. 1,080. So I'll put 1,080. And I have one decimal place between these two factors that I did. So that means I'm going to move the decimal point one place to the left. So basically that's going to give me the number 108. Now I still need to multiply by 60. But to save myself a little bit of time, remember I have a trailing 0 here. So I can just basically do 108 times 6 and then attach a trailing 0 to the end of that. So 108 times 6. 6 times 8 is 48. 8 down, carry the 4. 6 times 0 is 0. Plus 4 is 4. 6 times 1 is 6. So that's 648. And then we're going to put a trailing 0 at the end. 648. Put a 0 at the end. It's 6,480. So let me erase this. And we'll put that this is equal to 6,480. And then the units again will be minutes. Hello and welcome to Pre-Algebra Lesson 48. In this video, we're going to learn about converting between metric units. So again, the lesson objective for today would be to learn how to convert between metric units. And for most of you watching this video, you're going to live in the United States like I do. We don't really deal with the metric system that often, but it is important for us to get a general understanding of the metric system and how to convert between the units because at minimum, it's going to come up on one of your tests in the future. All right, so let's start out by looking at the commonly used metric units. So we have three that we're going to cover today. We have the gram, that's for weight. We have the liter, that's for volume. And we have the meter, that's for length. Now, one of these I know that all of you have seen. The liter is used when you buy a 2 liter of Coke or Sprite or Pepsi or whatever soda you'd like to consume. Now, one thing that's different about the metric system, when we have values that are larger or smaller than the basic unit, we use a prefix. So when we talk about prefix, that's a word that's going to come before the basic unit, right? So we put a word before we say gram. And here are our prefixes. So the first few we're going to look at represent larger values than the basic unit. So we have kilo, which stands for 1,000. We have hecto, that stands for 100. We have deca, that stands for 10. Now, when we start talking about values that are smaller than the basic unit, we have deci, that stands for 0.1 or 1/10. 1/10. We have centi, which stands for 0.01 or 1/100th. And we have milli, which stands for 0.001 or 1,000th. Now, let's see an example real quick of how we could kind of use this prefix. If we know that kilo stands for 1,000, if I had 1,000 meters, instead of writing 1,000 meters, I could just say I have a kilometer. So we could say that 1,000 meters is equal to or is the same as 1 kilometer. And that's all you're doing. You're just taking this prefix and putting it before the basic unit meter. If you had 100 meters, you could say that you had a hectometer. So you had 1 hecto. I'm just putting that word hecto before I put meter. And let's skip a few. We'll come down here to, let's say, milli. So if I had 1,000th of a liter, let's say, I could say I have a milliliter. So 1,000th of a liter, or in decimal form, you could put 0.001 of a liter, is going to be equal to 1 milliliter. So I'm going to write M-I-L-L-I and then follow that with liter. So the prefix is not too difficult to understand. You just take that part and put it before your basic unit. All right, so let's look at a basic conversion. So we want to convert 5 kilograms to grams. Now I'm going to kind of show you the slow way to do this, and then I'm going to kind of show you the trick, which makes metric conversion an absolute joke. Right? Once you see this trick, you're going to be like, wow, this is easy. So to go from 5 kilograms to grams, let's use our knowledge of what we did in the previous section when we converted between US units of measurement. Let's identify the relationship between kilograms and grams. I know that kilo stands for 1,000. So what this is saying is that I have a relationship that is 1 kilogram is equal to 1,000 grams. So if that's the relationship, and I'm trying to go from 5 kilograms to grams, remember we write a unit fraction with the units that we want to end up with in the numerator. So I want to end up with grams, so I'd put 1,000 grams in the numerator, 1,000 grams, and I'd put 1 kilogram in the denominator. And I just multiply by what I'm trying to convert. So I have 5 kilograms here. 5 kilograms. And the units I no longer want are going to cancel. Kilograms and kilogram. And basically all I need to do is multiply 5 times 1,000, and then my units will be grams. So 5 times 1,000 is, of course, 5,000. 5,000. And then grams. So that's pretty easy to do. Again, when I show you the simplified method, it's going to be even easier. But one thing you can kind of look at and rationalize here, if each kilogram is 1,000 grams, and I have 5 of those, well, yeah, then of course I have 5 times 1,000, right? 5,000 grams. So an easier method is to look at a prefix chart. So a prefix chart is a chart that has everything in order based on the number 10. And let me explain that. So we started out at the unit. If I start out at the unit and I just put the number 1, as I go to the right, I'm looking at smaller values, and so I'm dividing by 10. So to go from the unit to deci, I take 1 and I divide by 10, and I end up at 1/10. Or you could write 0.1. Then to go to the right one more time, to go from deci to centi, I divide by 10 again. If you think about 1/10 divided by 10, or 1/10 times 1/10, that's going to give you 1 over 100. Right? Or again, in decimal form, 0.01. And then if I go to the right one more time and end up at milli, I would divide by 10 again, or multiply by 1/10, and I'd end up with 1,000th. Or again, I could put 0.001. Now, as I go to the left, notice I'm just multiplying by 10. So this times 10 will give me this. This times 10 will give me this. This times 10 will give me this. And once I start going to the left over here and working with whole numbers, it's really simple. 1 times 10 is 10. So deca, remember that means 10. Multiply by 10 again to get to hecto. Remember, hecto means 100. Multiply by 10 one more time to get to kilo. Remember, kilo means 1,000. So now we can see that this is based on the number 10. Right? If I'm moving to the right, I'm dividing by 10. If I'm moving to the left, I am multiplying by 10. And that should be familiar to you from working with place value, right? If I come out and put, okay, the 1s, the 10s, the 100s, as you go to the left, you're multiplying by 10. As you go to the right, you're dividing by 10. Same thing here. Now, when we encounter a problem, like let's say what we just worked with here, convert 5 kilograms to grams, you're going to look at your prefix chart, and you're going to identify the starting prefix. So in this case, if we're going from 5 kilograms to grams, I'm starting out right here at kilo. And I want to end up at grams, which is the unit, right? The basic unit. So what I want to do is match the movement and the direction on the prefix chart with my decimal point in what I'm trying to convert. So for example, if I'm going from kilo to the basic unit, right, for grams, I'm going to go 1, 2, 3 places to the right. So with 5 kilograms, I'm going to put 5, I'm going to put my decimal point, and then I'm going to go 1, I'm going to put a 0 in, 2, I'm going to put another 0 in, 3 places to the right, and put a final 0 in there. And I can put a decimal point at the end, or I can leave it off. The number is 5,000. And then I would just write my new units that I'm going to, right, which would be grams in this case. So no complicated unit fraction involved, no multiplication involved. I'm simply looking at a prefix chart and matching the movement and the direction with my decimal point for what I'm trying to convert. It's that simple when you work with the metric system. The only thing you might struggle with is memorizing this part right here. And a lot of students will remember king for kilo, Henry for hecto, died for deca, unexpectedly for unit, drinking for deci, chocolate for centi, and milk for milli. So king, Henry, died, unexpectedly, drinking, chocolate, milk. So hopefully you can remember that. If not, again, if you just kind of write out the prefix chart a few times while you're doing some examples, you will memorize it. Okay, for the next one, we want to convert 4 millimeters to decameters. Now, all I need to do is write this number 4 down. Write the number 4 down. And I'm going from millimeters, so this is where milli is, that's your prefix, to decameters. So deca is right here. Now I'm going to match the movement and the direction on the prefix chart with my decimal point. So I'm starting here at milli, and I'm going 1, 2, 3, 4 places to the left. So I just need to match that over here. Let me just kind of back this up. So let me put 3 zeros to the left of this 4. So 1, 2, 3 zeros. My decimal point for the number 4 starts here. And then again, I'm just going to move it 4 places to the left. So 1, 2, 3, 4 places to the left. So it would go right there. And then once you're done with that, just write in your new unit. So we're converting to decameters. So that's what I'm going to write. Decameters. So 4 millimeters is going to be equal to 0.0004 decameters. Okay, let's take a look at another one. We have 3.8 kilometers, and we want to convert that to millimeters. So look at your prefixes. Again, you're starting out with kilo, and you're going to milli. So here's kilo, here's milli. So you're going all the way across the map. So let's write that number 3.8. And we're going to move our decimal point 1, 2, 3, 4, 5, 6 places to the right. So that means I'm going to need to place 5 zeros behind the 8. 1, 2, 3, 4, 5. So this is going to go 1, 2, 3, 4, 5, 6 places to the right. And let's just erase all that. Put some commas in. And we'll get 3,800,000. And then we convert it to millimeters. So we'll put millimeters behind that. All right, let's take a look at another one. We want to convert 3 milligrams to hectograms. So again, look at your prefixes. You have milli here. You have hecto here. So here's milli. Here's hecto. So let me go ahead and write this number here. We have 3. And we're going to be going to the left. Let me kind of write that a little further over here so that I have some room. And we're just going to match the movement and the direction on our prefix chart. That's all we need to do. So we're going to go 1, 2, 3, 4, 5 places to the left. So I would need to go and add in 4 zeros here to the left of the 3. 1, 2, 3, 4. So I can move this 1, 2, 3, 4, 5 places to the left. And I'll end up with 0.00003 and then hectograms. So hectograms. All right, for the final problem we're going to look at, we have 5.42 centiliters to decaliters. So you look at your prefixes, you have centi and you have deca. So here's centi and here's deca. So let's write down our number. It's 5.42. And I'm starting at centi and I'm going to deca. So I'm going 1, 2, 3 places to the left. Let me kind of move this over to the right a little bit. And I'm going to put in 2 zeros to the left of the 5. And so this is going to go 1, 2, 3 places to the left. And I'm going to end up with 0.00542 and then decaliters. Decaliters.